So I want to make a little space shooting game so I can use it to learn how to do some multiplayer gaming. So if anyone asks me, there's probably 3 tutorials I could point to for making a object fly around. That's this one here. This one here, which I've played the web demo, but I haven't looked at the project at all. And this one here. Now this one is very complex, so it's a really good one, and I've made it, but I just personally had a hard time controlling it because it's more of a helicopter simulator. So there's some 3 good ones. What we're going to do is we're just going to have a look at this because it's very simple, yet what it does is quite astounding. Does a couple of clever tricks using these rotations. Okay, it's in C#, but I'll just convert it as I go through. So it's pretty much set up like my NPC character, where it has a rigid body, but it rotates the object, and then it just sets the velocity in the forward of that object. So it has a move speed and rotation speed. Okay, so as described in a real cool picture up the top, there's 3 inputs. It's going to be the pitch, the roll, the yaw. So the pitch is your up and down, your roll is your anti-clockwise, your clockwise, and your yaw is turning to look to the left or to the right. Okay, so it takes some inputs, multiplies them by the speed and time delta time. Okay, so here's where it happens. This is the first real good trick. So it constructs a Euler angle out of the 3 inputs. Okay, and then if you wanted to add 2 rotations together, you actually multiply them. So it creates a Euler angle based on the inputs, and then it multiplies that to the current rotation. And it's very clever. So it adds that rotation onto the rigid body, the ship object's transform rotation. Okay, and then the final bit I was saying, is simply, this is quite a very tricky way of finding the transform forward, these 2 lines here. Adpos could quite easily be swapped out with transform forward right here. But again, it's quite clever. It uses the trick. You can get a directional vector from a rotation and a vector 3 if you multiply the rotation first by the vector 3. You can get a directional vector that way. You have to do it that way around. You have to be rotation multiplied by directional vector 3, and then you'll get the new direction vector. So yeah, that's about it. That's exactly how this is all put together. So we're just going to make a version of that. I really like the picture, so I already jumped into Blender to make a bit of an object instead of just having a cube flying around. Was inspired by that. So I am going to calculate my normals. I haven't done any animation, so I'm not even going to import any. Apply that to see. Okay, the wings look like they have fixed up on the shadows now. Okay, so this is quite a big object, as you can see. And I've got it facing the right way. That's awesome. Okay, I'm not much of a modeler, so I just want to see something flying around. Let's create a cube. Zero that out. Because I do know it's 16 meters long. There we go. So the cube's showing 16 meters long. Just want to get a scale up to get my wingspan. So it looks like wingspan's nearly 18. It is, yeah. Okay, so that's 16 by 18. I wanted it to fit in a sphere. Okay, so I've got my ship object ready to go. So let's build something that will fly this around. Folder, explore, scripts. And this is going to be ship movement. Put all this date stuff in and not even filling them out. Ship movement. Okay. So we have a variable which is going to be input vector 3. Okay, should I do it that way first or just rebuild his script first? Okay. Well, no, I will split it up. So let's get inputs, because I'm going somewhere with this. And what we're going to do, apply inputs, movement. So every update we're going to get inputs. I'm going to apply inputs to the movement. Okay, so input vector 3 equals vector 3.0. And then we're going to bring in each vector. So I've got to think about this. Input vector 3.x should be just called input vector. Gosh. Okay, input vector. That's just going to annoy me having a 3 0 all the time. The input vector.x equals, so the x is the pitch, which will be the input y, input vertical. Input dot get axis vertical. Input get axis vertical. Okay, so that would be the x. Now the y. So the y axis would be your. I've got to get to the y because I haven't created a direction. Okay, so that will make the mess. Z. Okay, to rotate on the Z would be rolling, so that would be inputting on the horizontal. Okay, so there's X and Z. Now Y, I'm going to have to do this on key inputs for now, but I'm going to use Q and E for the yaw. Okay, so yaw type float equals 0. And if input get key code .q for left. That is going to equal 4 at the end of the day because I'm working out this input. Q and E is equal 5. Equals minus 0.99 going left. Equals positive 0.994 yawing to the right. So, and then you put X to Y equals the yaw. So that's getting all the inputs. You should see that working in the inspector already. So luckily no compile errors. Don't need animation on that. Let's put the ship movement on. Let's see if these input vectors are working. left, Z is -1. And that get axis is returning to 0. Forward and backward rotate me forward. Okay, we need to put an invert Y vehicle in here, input vector, because I'm an invert Y person. Okay, and finally that Y Q just immediately jumps to 0.99. Okay, so that's not an axis. We should set up an input axis in the inspector for that. But that's working for now. I've got the input vectors coming in. Inputs to movement. Now we need to start creating some other variables. So we can multiply these by a rotational speed. I'm going to have one for each axis. And then apply it to the actual rotation of the object. So we've got to store a reference to that.